帝京平成大学のここがすごい。国家試験合格者数全国優秀、充実したイギリス留学生、プロ野球チームとコラボレーションした授業、帝京魂、帝京平成大学。
ファミリーマートのおむつにはゼッティのベルマークがついています。また先頭で回収したベルマークは最寄りの小学校や災害で被災された地域の小学校に出動しています。皆様のご協力をお待ちしています。ファミリーマートから T マネーについてのお知らせです。お手持ちの T カードが電子マネーとして使える T マネー。小銭いらずでスピーディーにお会計ができ、T ポイントがさらに貯まります。毎週水曜日と金曜日はファミリーマートで T マネーをチャージすると1日に T ポイントを5ポイントプレゼント。ファミリーマートでは毎週水金チャージの日。ファミリーマート夢の架け橋募金。お客様からお預かりした大切な募金は国連 WFP 協会、セーブ・ザ・チルドレン・ジャパン、国土緑化推進機構、友達イニシアチブの4団体に寄付し、子どもたちと地球の未来のための活動に使わせていただいております。皆様の温かい
なんかコンビニでも高速バスとか飛行機とか予約できるみたいです。
It may be the packing, and maybe, it may not be that the packing is uniform in itself. Maybe it's, it's in sort of clumps. And so you get, activate, trigger, calcium, big release, big release, big release. So it's sort of almost, in a stepwise.
So you see that it's saltatory?
Almost saltatory. Yeah, that was the word I was looking for.
But even if
we don't see that, but we just don't know yet.
Yeah, we don't see it.
Well, we don't see it, but that doesn't necessarily mean, because that has to do mean that it's not happening on a a nanoscale for all we know. We just don't know anything about the packing of the random receptors in the atrium yet. As far as I'm hoping that nobody's actually measured it, because that's what I want to do. Yeah.
Sorry to kind of intervene into this discussion. I'm definitely not a specialist in these. I have only talked about my impressions from other authors, what I saw. But probably it's related to plugging, yeah, good. And probably it's related to particular dye you use. So in your nice pictures you see only T-tubules and nothing else. But in real cells, when you show this heart failure ventricular myocyte, it's not empty. There is something. Do you know what is there? In this where there's no big area where it doesn't show any T-tubules. My guess is, from what I saw from some publications by colleagues at University of Melbourne, it's actually mitochondria. So when you say about, let me finish, when you talk about organization of T-tubules in a cell, it's actually not the cause, it's a symptom. It's a symptom because of changed mitochondria. Changed mitochondria in hypertrophic cells. And so the failure of calcium signaling is just a symptom of the cell struggling for energy supply. And that is why a huge enlarged mitochondria, that is why disorganized tissue. So what you show is not how to measure these.
I am not going to categorically say that that's not true. I don't know the answer to that. I don't have any evidence for it. I've not studied it. I mean, yeah, I could take a look. I could stain the mitochondria in some of these cells. That's a very good idea, and see if it really fills in. I mean, as far as I know, you're still getting calcium release there.
Yes,
Yeah,
of course.
and you would not get that from.
You still need calcium signaling, but calcium signaling, it looks like the cells actually sacrifice calcium signaling for energy, which without energy it will die anyway. So in this abnormal condition, it's one going for another.
Yeah. No, that's a really interesting idea, and I'll try to take a look at it by staining in the heart failure cells and all heart failure cells to see if there's some sort of gross change in mitochondrial size or density.
Measurements of organization in the system, so one, that is very good, but that is the symptom, not the cause.
Of heart failure?
Of hypertrophy and mitochondrial change because of that.
Yeah, I have no comment on that. It's a very good idea. Sure, it could be. Now, one thing I will say is that we get plenty of calcium transients in those regions where there are. I hope. Yeah. So the calcium transients are surprisingly normal there. So it's not like there's I mean, you started by saying, well, what's in that space? And I said, well, you're going to have myofilaments, you're going to have SR, you're going to have ryanodine receptors. You're probably going to have pretty much everything that you should have in the absence of T-tubules. But I certainly can't deny the fact that there's very likely to be, and it's a very good idea, that there could be a totally different density, organization, and so forth of mitochondria. Yeah.
So I'm embarrassed by how little I know about T-tubules, but
you're not alone. But they're not embarrassed.
What?
They're not embarrassed.
Oh. But at the beginning of your talk, you said that it has some implications for arrhythmia, and I wonder if you're going to be able to get to that in the talk.
That's up to the assembled multitude.
I was going to let you get to that in the talk because I'm really interested in the implications for arrhythmia.
All right. I'm actually fairly close to that right now.
Okay, great.
So we're going to jump over these. Okay, so now this is actually the threshold limit, so I wasn't too far. Okay. So now what I'm going to do is I'm going to talk a little bit about how the change in T-tubule organization affects EC coupling. And of course, once you start talking about EC coupling, you're talking about calcium, and that's where we talk about the arrhythmia. So I will take this prompting and mush on. So here we have some calcium transients in normal ventricular myocytes, and at different pacing rates. Here's the cycle length: 1,000, 500, 400, 300, and you can see that the It's not as nice as the rat, but given the change in density in T-tubule, the difference in density in T-tubule organization in the dog compared to rat, that's not a big shock. But when you go to the heart failure, things get pretty ugly. And for those that notice that there's a number of units in Alternans. This is a very nice model. Section of the cell, but you can see that at the point of the beginning of the rise, where the action potential triggers calcium entry, you get an initial release, but look at all the regions of the cell that take so much longer to release their calcium, and it gets even more profound as you go faster, and here you get a really quite astonishing degree of alternans, and it's really just sort of blotched in terms of its release as you go faster and faster, and here you have almost no release. And here you're going so fast that you get a little release at this end of the cell on each beat, but the point is the fragmentation and the heterogeneity in release becomes very much exaggerated as you go at faster rates. I am not going to go through this for purposes of time, but if you look at the heterogeneity of release, the variability along the cell length, as I mentioned, it gets profound as you go into more severely detubulated cells.